The purpose of this lesson is to learn what a class is and how it works, how to instantiate a class object, object and class properties, the public and private modifiers, how to use the this reference, constructors and initializers, and then also how to use deconstructors. In C#, everything is a member of a class and everything is an object. And an object is nothing more than an instance of a class. Each object can have variables, which are attributes. They can have a state, specifically what is the current status of that. Is it active, not active? It can have methods, and then it can also have access modifiers. When we create a class, we need to declare the attributes and the methods. So the attributes are going to be things like variables. So if I have a class is kind of like a blueprint. Now, I could have a class of objects that are things called automobiles, but I didn't actually make an automobile. I just simply made the blueprint for one. Or I can have a class of objects called houses. And once again, I didn't actually create a house, I just created a blueprint for it. So what we're going to do is we're going to specify that a house has attributes like house color, and a house has attributes like number of rooms and number of bathrooms. An automobile has things like color, and it has things like number of doors, and it has things like roof type. But I didn't specify what the roof type is, or what the color is, or the number of rooms, or the number of bathrooms. I just simply specified that it has those. It's not until we actually create the real automobile that I actually take and build one specific instance of it, or until I build the actual house, that we actually worry about the actual number that are going to be in there. So when we create an object, we have a two-step process. The first step is to declare a new instance of it. So we're going to give it a name, which what that does is it will set aside some space in memory to hold that object and all of its attributes and all of its methods. We're going to call what's called a constructor to actually build that object for us. The constructor and all of the other stuff that is declared for that object will have its own memory space, but it will exist inside of the namespace of our actual program. So make sure you know that when we create a class, we are creating the blueprints. When we create an object, we are instantiating an exact object that is inherited from that class object. Alright, so we have some properties. So a lot of the things that we have, things like if I build a new car, I need to set the number of doors, and I need to set the number of wheels, and I set the type of roof, and I set the engine size. And then later on I may need to find out how many doors there are, so I would get the number of doors, and I would get the color, and I would get the roof type, and so forth. And if we have something where I create an object where we just simply set values and get values, we can use what are called auto-implemented properties. Whenever I create an object, while I am manipulating that object, there's this thing called a this reference. This is just simply the memory location of the object that is currently being used. So this is nothing more than a memory location, but what it does is it allows us to distinguish between two different objects that are in memory, one that we're currently working with and one that is maybe stored somewhere else, or even the class object itself. Now it's going to be a little confusing to understand. Hopefully I'll make it a little bit more clear for you here shortly. Whenever we make an object, we have a thing called a constructor, and a constructor just simply is a method that is used to create the object. Now the constructor can be what's called a default constructor, which is one that is just automatically created, or it could be one that we could specify exactly how the object is created. Maybe we want to set it where when an object gets created, then if I create a new car, then we're going to automatically set the number of wheels to 4, and when we set or create the car, we set the number of doors to 2. Now we can override that stuff later, but by default we're just simply going to create those properties. Now the constructor, we have to at least use what's called a default constructor, which is the one that the system will use to create a new object, but if we want to, we can create our own constructors. After we are done with an object, if we decide we no longer need a particular object, it gets deconstructed. And deconstructed means that all of the memory locations that are used for that particular object get cleared out. And this is a process called junk collection. The system will automatically handle deconstruction for us, but sometimes we'll want the system to do something else. So the programmer could decide that we want additional tasks to be performed. So let's say we were using a file or a database or something like that, then we need to close the file when it gets deconstructed, or we need to close the connection to the database, or maybe we just simply need to alert the user. And the way that we do this is we put a tilde in front of the name of the constructor, and it will allow us to tell it additional features that should be performed when we deconstruct that. Now, one thing to be aware of is when we deconstruct something, all of the properties and attributes for that particular object get deconstructed in the reverse order from how they were created. I'm going to make a new project for lesson 9, and what I want to do is I want to make a class of objects for automobiles. So I'm going to come down here and I'm going to say class automobile. And as long as I spell it right, there we go. So I have a class of objects called automobiles, and what I'm doing is I want to specify that an automobile has properties and then it has methods. So we have things, we have attributes. So these are going to be variables that are used for each one of these objects. Each one of these will also have methods. We can have constructors and we can have deconstructors. For right now, what we're going to do is we're simply going to leave it where we are making these automobiles where they have things like a brand and a model and a price and a number of doors. And then we're going to have some methods for actually getting and setting these. Now, one thing you need to think of is when you make a class object, think of having a stack of note cards. I have one note card, and by note cards I'm talking like index cards, little 3x5 index cards. Makes it easy to understand. But I have one of those that is the blueprint for what every other one should look like. And so what I'm going to do is I'm going to make my first index card, I'm going to take it out, and I'm going to write the word automobile across the top of it. And then I'm going to specify that each automobile has things like a brand, a model, and a price, and the number of doors. And then I don't actually fill anything in for those. I'm going to leave them blank because that's our blueprint. Alright, so what I'm going to do is I'm going to make my blueprint. Alright, so what I'm doing is I'm going to create what's called a private string value. And private means that nobody from outside of this class is allowed to look at this value right here. Alright, so I'm going to call it str brand. And then it's also going to have something like the model, so I'll call it str model. And then we'll have price for it, so we'll have private double, DBL price, and then we'll have a private int num doors, so that way we can keep track of how many doors they have. Alright, so these are the attributes for any automobile. Every automobile that we have is going to have these attributes to it. Now these attributes only the class can see, so nobody else is allowed to see str brand, but we need to make some way for somebody to be able to see what the value is in here. So what we're going to do is we're going to declare some methods that are public, which means other people can see them, and the public method will be allowed to see str brand and tell the other person what it is. Alright, so what I'm going to do is I'm going to make a public, and this is going to be a string because it has to be the same data type as what we want to return. And then in curly brackets, this is what we're actually going to use. So we're going to do what's called a get method, and then we need a set method. Alright, so now get is going to just simply return whatever the value is of str brand. And then set will allow the user to set whatever they want into str brand. Now to do this, what we're going to do is we're going to set str brand equal to a keyword called value. And value is just simply a keyword or a variable that the system is going to keep track of. We don't need to declare value, it's just already declared. All right, now we have to do this with every single one of these. So I'm going to make another one of these for public string, and we'll call it model. And then we're going to have a public double for price. And then we'll have a public int for num doors. So notice I'm not calling this int num doors. I'm not calling it DBL price. I'm calling it just num doors and price. And the reason for it is this is what the outside world is going to see the name as being. So think of it as being that index card, and I want to see car 1's model, and I want to see car 1's price and car 1's number of doors. And I don't want to care about car 1's STR model. I want to care about car 1's model. All right, so I have to do the exact same thing that we did here for every one of these. So we're going to have a get, and we're going to have a set. Okay, so just to cheat, I'm going to copy these, because it's going to be exactly the same in all of these. And then what we're going to do is we're going to specify that we are returning STR model, and we're going to set down here STR model is equal to value. This one here is going to be return DBL price, and this one's going to be DBL price is equal to value. And I forgot a semicolon here. All right, then this one's going to be return int num doors, and then this one's going to be int num doors is equal to value. So once again, we're using the same keyword. So notice, I mean, this is a lot of text that I had to type out for these, and the reason for it is because I'm specifically stating what the get and the set is for every one of these. Now I can also make this shorter, so I'll show that to you here in just a couple of minutes. But this is the full drawn out, here's how to type everything yourself using these attribute names that I have declared and not using the auto-implemented attributes. Alright, so I created the blueprint for an automobile, but I haven't actually made one. And where I'm going to make one is going to be up here in the main method. So what I'm going to do is my console.read at the end here, just so I don't forget to do it. Alright, so what I want to do is I want to make a new instance of my automobile. And so what I'm going to do is I'm going to start typing the word automobile, and if you notice, if I type it, it shows up as an available class. And notice when I hover over this, it says class lesson 9 dot automobile. It knows that this is a class in this project. All right, so what I'm going to do is I'm going to call it car, and I'm going to set it to a new automobile. Okay, now this one is going to be the constructor for it. All right, so now what this is the constructor is the default one. I'm not sending any parameters to it. I'm just simply stating, hey, make a new automobile. And I'm letting the system use the auto-implemented or default constructor here, but I'm making a new object of the class automobile, and I'm going to call it car. Now what this means is that I can reference car. Okay, now I can do is set car.brand and set that equal to something. So we're going to make this a Ford Mustang. All right, so now car.model is going to be equal to Mustang. And then car.cost is going to be equal to 25,000. And car.numDoors is equal to 2. So now what I'm doing is I'm declaring that we have a car, and actually I said cost here, but it's not cost, it's price. Okay, so I have a new car, which is a type of object of a class called automobile. This is my blueprint. This is my actual instance of it. So now I've made a real object. And for my real object called car, I set the brand. For my real object called car, I set the model. For my real object called car, I set the price, and so forth. All right, I want to make another one. And this time, instead of being the car, I'm going to make a truck. So I'm going to make a new type of the class automobile. I'm going to call it truck. And this is going to be a new automobile with the default constructor. Okay, now I can reference truck.brand, and this is going to be a Chevy. And I can do truck.model, and this is going to be Silverado, and truck.price, and we're going to set it equal to $46,000. And then our truck.numDoors is equal to 4. It's a 4-door truck. Okay, so what I've done is I've just made 2 instances of my automobile class. One is a car, one is a truck. Now what they're doing is they're both inheriting properties from the parent class object. They're inheriting that they have a brand, they're inheriting that they have a model, they're inheriting that they have a price, and they're inheriting that they have a number of doors. And so what this does for me is it makes it where I can have however many objects I want. And remember I said think of them like index cards. So I pulled out an index card, I wrote the word car across the top of it, and then for the brand, model, price, and number of doors, I filled in those blanks. Where did those blanks come from? The blanks came from the blueprint. Okay, I took out another index card, I wrote truck across the top of it, and then I filled in the blanks for brand, model, price, and number of doors once again, which came from the class. So what this does for me is it makes it where I can have an unlimited number of objects. Each one has its own card, and I can call them individually now. Okay, so now what I want to do is I want to write out to the console the Ford Mustang with so many doors costs so much. Okay, so where do those come from? Alright, so the first one is going to be car.brand. The next one is going to be car.model. The next one is car.numDoors. And then the last one is car.price. Okay, so now I'm going to do the same thing with the truck. So console.writeLine, the Chevy Silverado with a certain number of doors costs so much. Okay, so now this is truck.brand, truck.model, truck.numDoors, and truck.price. Okay, so now what I'm doing is I'm making it where I can read the data in from those cards. So this is the set. When I do this, I'm telling it to use the set method right here. I'm sorry, this one right here, set it. When I'm doing this one, I'm telling it to get it. So notice it's a return. Alright, so if I run this, I now end up with the Ford Mustang with 2 doors costs $25,000 and the Chevy Silverado with 4 doors costs $46,000. So I've written the stuff, I've set the stuff on the index cards, and then I get the stuff from the index card so that I can read it and do stuff with it later. I wanted to do one more thing with this price here. The price doesn't look much like a price when it prints out on the screen. Most attributes that we have additional properties that are available. So if I put a dot here at the end, you'll notice that we have some additional functions, and one of which is called toString. And what I can do is I can send it to the toString function, which is a method, and if I put a capital C inside of parentheses here, it'll tell it to format it as currency. So I'm going to do the same thing here. I'm going to say toString, and then now what will happen when I run this, now it will format these like currency. So we get our $sign and we get our commas, so more like what we're used to seeing for money. It will automatically format those things for us. So now what I've done is I've just simply created a new new automobile called car. I've created a new automobile called truck. I set all of the values for the attributes, and then I've set all the attributes for the truck, and then I get those, so I read them back from the card and display that information out to the screen. Alright, I want to show you a shortcut way of doing all of this stuff for the methods. But I'm going to need this longhand like this, so for right now, instead of actually deleting it, I'm just going to simply comment it out. And so far I've used inline comments like this, but what I'm going to do is use what's called a block comment, which is a / and asterisk, and then it ends with another asterisk and a /. Alright, so what this will do is it comments out that entire section, and in that way I don't lose that, but it actually won't use it. Alright, so what I want to do is I want to show you how to use this and be able to do this exact same thing without having to type all of those lines of code. And actually I put this in the wrong location, so I'm going to move this up a little bit. Okay, so it's actually all of this that we don't need. Okay, so what I can do is I can use what's called a default get set. And remember I said that I made this private because I don't want somebody else to be allowed to look at it, and I gave it a variable name. Well, what I can do is I can make a public string for brand, and then at the end here what I can do is in curly brackets I can do get set like this. And then now what this does for me is it makes it where anybody else is able to reference the brand, and it will automatically get and set it. Now this only works if we're going to use things where we actually get and set them. So if I do public model and then get set, and then public double price get set, and then public int num doors. So now what this is the exact same thing as what I had with all of these lines here. It's just a shortcut way. Now what I've done is instead of specifying that there is a variable name called strbrand, I am simply going to allow the system to make its own variable. So it'll ignore this. But what that means is that I can't know what they call the variable. The system just automatically does it. And this program will function exactly the same way, because all I did is I just simply used the auto-implemented property here of the get and set modifiers. So these, get and set accessor and mutator methods. So what we're doing is we're just simply allowing the system to create its own variable for it to keep track of whatever variables it wants for those attributes, and I'm just simply getting and setting those. So anytime I have an attribute that I don't necessarily need to do anything other than get it or set it, I can use one of these. If I need to do anything else with it, I have to do the longhand way, which is what we're going to be doing next. So I'm going to go ahead and delete these, because for what we're doing for the rest of this, we are using the longhand way, and we're going to add some additional functionality to our program. Alright, I referenced this reference, and this is going to be when I'm actually working with an automobile. The attributes up here are what are this reference. So I have this STR brand, I have this STR model, I have this DBL price, and this int num doors. And what I'm talking about is that when I pull up my index card, if I look at the values on that index card, each one of those is referenced by this. This is just simply the memory location of the entire card. Alright, so what I'm going to do is I'm going to get in the habit of down here, instead of just simply returning STR brand, I'm going to return this dot STR brand. And down here I'm going to set this dot STR brand equal to value. And same thing here with STR model, it's going to be this dot STR model. And then also for DBL price is this dot int doors, or int num doors, and then this dot int num doors again. Alright, so what I'm doing is I'm telling it that I want to set the value that comes in to be this dot DBL price. This refers to all of these. So if I say this dot STR brand, I'm talking about this. If I'm talking about this dot STR model, I'm talking about this. So it just makes it where the system can keep track of, I'm talking about the attributes for this one particular instance of this class. So if I run it, I get the exact same results, but what it'll do is later on, if I try to do a comparison between two cards, I can do it and the system won't get confused as to which one I'm talking about. Alright, so I want to make it where if we sell a vehicle, that we're setting the price of the vehicle to a certain amount, but we always want to add an upcharge of 10% to every vehicle that we sell. So the price of this vehicle from the factory was $25,000, but what we want to do is we want to always add that to, add 10% to that and then put that on the sticker for the customer to purchase it. All right, so what that means is that we're going to no longer allow people to directly set the price here. So I'm going to delete this section of code for setting the price. I'll still allow people to get the price of it, but I'm not going to allow somebody to set it directly. What I'm going to do instead is I'm going to come to the end here and I'm going to make a method that is responsible for setting the price for me. Alright, so what I'm going to do is I'm going to make a public method that doesn't return anything, but what it does is it sets the price. Okay, and what it does is it's going to accept a double value that I'll call DBL price. Alright, now the thing is that this method, if I send in $25,000, $25,000 gets sent into here, and then I have a DBL price here that I want to use to manipulate DBL price up here. Remember, this one up here is called this.dbl price because these attributes are always the this reference. So what I want to do is I want to take whatever this price is, multiply it by 110% of the original price because I want a 10% upcharge, and then I want to reset the price up there to be whatever this is. Okay, so I want to make a constant variable. Remember, a constant, not a constant variable. I want to create a constant double, which, remember, a constant is just simply a memory location that its value cannot change. And we're going to call this upcharge. And we'll set it to 0.10. So this is our 10% upcharge on every vehicle that we get. Alright, so now we have upcharge, and what I want to do is I want to take whatever the price is, this $25,000, and multiply it times 1.10 because I want it to be 110% of the sales price. So I'm going to take DBL price, whatever DBL price is, and multiply it times 1 plus whatever the upcharge is. Okay, this is the same as saying 110%. Alright, and I'm going to take this and I want to set DBL price to be equal to this. Well, the problem is I want to set DBL price up here, DBL price. But I have DBL price here, which is actually this DBL price. And I don't want the one here, I want the one up above. So what I have to do is I have to specify this .dbl price. Remember, this is the reference for the attributes for our card. DBL price here is the one coming in from whatever calls it. Alright, and then what we're going to do is when we call this section of code, instead of setting the price, we're going to do car.setPrice. And instead of setting it equal, we're going to pass a value. And the same thing with the truck. We're not going to set the price directly because we have no way to set it. We have set price, and we're going to pass a value. Okay, so now this vehicle originally cost $25,000, but what it should do is automatically add 10% to the price. And this vehicle cost $46,000, and it should automatically add 10% to the price. So now when I run this, I now get that the Mustang cost $27,500 and the Silverado cost $50,600. So even though the price of these was originally $25,000, what we do is we call the section of code that's responsible for setting the price. That section of code automatically adds the 10%. It sets that 10% increased value to the attribute, and now the price is permanently the increased price with 10% added to it. So what this did is it allowed me to set a 10% upcharge on the price of the car, and from now on that's what the price of the vehicle is. So if I were to look at DBL price, that would be the increased price. It's no longer the $25,000 or the $46,000. Alright, I want to shorten my code some, and we're going to do that down here. You'll notice that I still have some values that are set and get methods. Okay, so for this right here where we have the brand, what I want to do is I want to make this how we get and set it. All right, which means that I no longer need the brand up here. So I'm just simply going to make this get set. Okay, and what this does for me here is I can get rid of all of this. And then up here, I can get rid of the str brand. Okay, so what I'm going to do is I'm going to clean all of these up. The model is the same way. The model is going to be a get and a set. So here, once again, for the model, I don't need the longhand way. I can do this the shorthand way. And it automatically puts spaces, but it didn't put them because of the way that I created it. All right, and then now our DBL price, though, I can't do that with price because price is using only a get method. All right, so I have to leave price alone, but here for the number of doors, I can do this for the number of doors. All right, so I'm going to delete this, delete the number of doors here, and the num doors is going to be get set. Oops. Get set. All right, so what this is doing for me is just kind of shortening my code a little bit. And we'll do this, we'll put those all together so that way all the ones that are the accessor or the default accessor methods, we can leave those together. And we're just simply making the code look a little nicer here. All right, so I want to run this just to make sure that it still works. Still works exactly the same, but now our code is significantly shorter. I can also shorten this up here, and what I can do is when I make a new automobile, I use the default constructor here, but I don't actually have to use the default constructor. I can use my own. And the way that I'm going to do this is instead of saying car.brand, car.model, and car.numDoors, if it's something where I'm just simply setting it, I can change this. And the way that I would change this is to get rid of the parentheses here, and inside of a set of curly brackets instead, I'm going to say brand, model, numDoors. Those are the ones that are available to me. So I'm going to set the brand is equal to Ford, the model is equal to Mustang, and the number of doors is equal to 2. All right, so what this is doing is making it where I can get rid of this stuff, and I can get rid of this. I cannot do it for set price because that's actually a method that I have to call. All right, so I can do the same thing here for the truck. I can make the curly brackets, and then we're going to do brand is equal to Chevy, model is equal to Silverado, and then the number of doors is equal to 4, which means once again I can get rid of these two lines here, and I can get rid of this line, and now my code is much shorter. So now I have an automobile, which is a car, which has a brand, a model, and a number of doors, and then it has to set the price. And then I have a truck, which has a brand, model, and number of doors, and we have to set the price. Down here below, the brand, the model, and the numDoors use the default get and set methods. And then we have a get method only for the price, and then we have a method for setting the price down here. So the program should still function exactly the same. We just have significantly shorter code here. So we've actually cleaned up the code quite a bit. I want to show you how a deconstructor works. Now, after this object is created and everything is done with it, then the system will automatically deconstruct it. When my program ends, it does junk collection, which means it will automatically clean up everything that's left over. But I want to tell the user that this occurred. So what I'm going to do is at the end of my class, I'm going to use a tilde, which is to the left of your 1 key on your keyboard, and I'm going to type the name of my constructor, and it is a method, so it gets parentheses. And then in curly brackets, I want to specify what should occur when the object gets deconstructed. Now, by default, the deconstruction occurs, nothing actually happens on the screen, we don't see it. But what we'll want to do is things like close a file if it were open. If we had a connection to a database, we'd close that. In this case, I just simply want to let the user know that it was deconstructed. So I'm going to do console.writeLine, and we're going to specify that the whatever vehicle, so the Ford Mustang, has been destroyed, just to let you know that it has been. And the way that I reference this is brand and model. All right, so what will happen is when the object is deconstructed, it should pop up on the screen to let you know. So when I run this, it tells you that the Ford Mustang costs so much, that the Chevy Silverado costs so much, and then it's waiting for me to press enter. Now when I press enter, the program exits. And before the program exits, all of the things that are made up of the program, they will all get deconstructed. The problem is when I press enter, you don't actually see it do it because it actually just exited the console. So if I were to run this from a command prompt, so I have the actual executable here in our debug folder. If I were to run this, it will actually tell me that it's deconstructed. So here's the exact same program, and it says that the vehicles cost so much, and then when I press enter, it will deconstruct both of those. Now notice it gets deconstructed in the reverse order. So we created the Ford first, then we created the Chevy. So the Chevy gets deconstructed first, then the Ford gets deconstructed. And the idea here is that we actually can do things along with our cleanup. The system will clean everything up for us, but it may not do everything that's needed, like it's especially with closing files and database connections. In this lesson, you learned what a class is and how it works, how to instantiate class objects, the different object and class properties. You learned the difference between the public and the private modifiers. You learned how to use the this reference, which is going to be specifying the attributes for the currently selected object. You learned about constructors and initializers, and then also how to deconstruct or destruct an object.